everyone, a very warm good morning to all of you. Well, actually it's noon, so good afternoon to you all. How are you all? I think everyone is doing great. Hello. Okay guys, so in the GOAT series, we will be continuing with our next live lecture, that is on acids, bases and salts. So, are you ready guys? Okay, so we will be covering acid, bases and salts through mind maps, and we will be discussing the top 15 most expected questions. So, the chapter name is acids, bases and salts, right? So, we will be talking about acids, bases and salts, okay? So, let's begin. In acid, bases and salts, we will be talking about three things: your acids, bases and salts, okay? So what are your acids? You all have tried lemon juice, right? How does your lemon juice taste? It tastes very sour, right? So, and have you ever tried little bit of soap by accident or something, you know? And how does it taste? It tastes so bitter. It does, right? Hi Sukhveer. So, what distinction is there, you know? Something is tasting sour, we call that acid. Something is tasting bitter, we call that base, right? Hello everyone. So, firstly we will discuss the physical properties of acids and bases. Physical properties of acids and bases. The physical properties. Some properties we all know. The one that is, your acids are sour in taste, your bases are bitter in taste, okay? So your acids are sour in taste and your bases are bitter in taste. Now, your acids, they turn your blue litmus red, right? When you have a blue litmus paper, they turn your blue litmus paper red. And your bases, they turn your red litmus blue. Okay, my dear kids? See, so your acids, they are sour in taste, while your bases, they are bitter in taste. Hello Bharat. Hello Sukhveer. Hi Sukhveer. Okay, so your bases are bitter in taste while your acids are sour in taste. Now, the next distinction, these all distinctions are based on their physical properties. You know, physical properties. When you are trying to distinguish some substance in chemistry, you do it by in two ways. First one is by physical characteristics, you know, what kind of way they look, what state they are in. Hello Rajkumar. Hello Ankush. AlCl3 is an acid or not? AlCl3 is not an acid actually. AlCl3, oh, it is a Lewis acid. It is a Lewis acid. I think it is acid. Yes, Bharat, it is acid. It is a Lewis acid. Hello everyone. Okay, so this is the basic distinction. Okay, that's how you distinguish between your acids and bases, physical properties wise. Okay, so how do they look, how do they taste, how do they smell, you know, that you can see with your own eyes. Then there is the other characteristic, that is their chemical properties. Okay, Sukhveer, okay, sorry, Balveer, but it is a Lewis acid, Rohit. Can we write it as an example? Well, you have so many example of acids. Yes, you can write AlCl3 as an acid. Yes, Ankush, you can. Okay, the next characteristic is your acidic solutions. Basically, when you have acid, when you make an acidic solution, when you dissolve your acid in water, they give which ion? H positive, your hydrogen ions. Okay, they give hydrogen ions in aqueous solution. In aqueous solution. While, hello the gamer, hi Rajkumar. I hope that clears your doubt, Ankush. Hydronium ions, hydrogen ions. So this is H positive, right? Your hydronium ions are H3O positive. Correct, Ankush. Okay, so your acids give H positive or H3O positive, either hydrogen ions or hydronium ions. That is in aqueous solution, when you make a solution of them. Okay. Hi Pikachu, what's your name? What about bases? Your bases give OH negative ions, OH negative ions in aqueous solution. Okay, when you make an aqueous solution of your bases, you get hydroxide ions. Okay, these are called hydroxide ions. Now, the next distinction is your bases, your acids, they conduct electricity. Why? Because they have ions, hydrogen ions, hydronium ions. Yes. So, that's why your acids conduct electricity. Okay? Okay, Pika. I can call you Pika. Yes. Now, your acids have a pH, you have a pH scale ranging from 0 to 14, right? That's your pH scale, ranging from 0 to 14. You have 0, here you have 14, here in between you have a 7. You call 0 to 7 acidic pH. Your 7 to 14 you call basic pH. And at 7 you call it neutral. Hello Bhuvnesh Kumar. So your acids have a pH less than 7. They have a pH from range of 0 to 7. Okay, Pika. While your bases have a pH greater than 7. While your bases have a pH greater than 7. pH table can vary at different temperatures. Yes, it can. The pH of milk is slightly acidic actually. from 6.4 to the pH of milk. The pH of milk is from 6.4 to 6.8. So as you can see, it is slightly acidic in nature. 6.4 to 6.8. See, you see so many acids, bases and salts around you. गर्मी में मिल्क, गर्मी में मिल्क बेकार हो जाता है. ओ दैट एसिड की वजह से ना, द बैक्टीरिया वर्क्स ऑन इट एंड इट गेट्स स्पॉइल्ड. ओके, pH of milk, yes, it contains lactic acid. That is very nice, Lenovo, if you completed 3 sample papers of science. So the 2025, 26, 2023, which one you completed though? See, Pika, what happens during summer? During summer the temperature is high, right? And in that temperature your bacteria grows very rapidly. It multiplies very rapidly, and because of that your milk goes bad if you do not warm it before. You do not kill the bacteria before, pasteurize it you call it, or boil it at a very high temperature so that the bacteria dies. That's why the milk goes bad during summers. During winters you can keep it, it won't go bad, itna jaldi nahi jayega. Hi Kushma, hello. You're late. No, you're not late, you're on time. 3, 4, 5. That is very nice, Lenovo. What's your name? Lactobacillus bacteria. Lactobacillus bacteria is like it's a different bacteria. It is used to basically when you try to convert your milk into curd, when you dahi jamate and everything, when you do that process, that bacteria is required, lactobacillus. Hi Bharatan, no, I'm not getting cold. Hello Choco. Ma'am. Okay Pradnya. I'm not Kusha, my. Okay, hi Vikas. Is it not present in milk? It is majorly present in curd actually. Hi Shivanshu. Okay, so your acids have a pH less than 7, your bases have a pH greater than 7. Now there is one more kind of bases that you called alkalis. What are those bases? They are water soluble bases. Bases that are soluble in water are called alkalis. They are called alkalis. Okay. Hi Shivanshu. Again lactobacillus curd में होता है, it's not in milk. Then there are few examples. We have 2 types of acids. We call them strong acids and weak acids. Why strong and weak? Strong acids dissociates completely in aqueous solution, while your weak acid, they dissociate only partially or incompletely. Partially dissociate होते हैं. They do not dissociate completely in aqueous solution. The examples are H2SO4, HCl. They are your strong acids. That is, as soon as you put them in a solution of water or anything, they dissociate completely. While your weak acid, they dissociate only partially in your aqueous solution. Okay, when you put them in an aqueous solution, they will only dissociate about 2-3%. Okay. Hi Harshit. Pradnya, my name is Ekta. As you could have, like, it's in the thumbnail only. My name is Ekta. You can call me Ekta Ma'am. So Harshit, we were just talking about the physical properties of acids and bases. How do you distinguish between an acid and base based on their physical properties? Okay, so the first one was the acids are sour in taste, your bases are bitter in taste. Your acids turns blue litmus red, while your bases turns red litmus blue. Your acids give H positive or H3O positive, hydrogen or hydronium ions in aqueous solution, while your bases give hydroxide ions, your OH negative ions. Okay, your acids have a pH less than 7, your bases have a pH greater than 7. Okay, there are two types of acid, strong acids and weak acids. What are strong acids? Your strong acids are those acids which dissociate completely in an aqueous solution. For example, your H2SO4, HCl, HNO3. Okay, your weak acids are those acids which dissociates only partially in an aqueous solution. For example, CH3COH, H2CO3, acetic acid and carbonic acid. This is your carbonic acid. Okay, so when acid rain comes, the acid that is released is carbonic acid. Okay, now again, two type of bases are there, strong bases and weak bases. What are strong bases? Again, they give OH minus ions in aqueous solution, strongly, completely ionized. As soon as you put them in solution, they will dissociate into OH minus ions. Okay, while your weak bases, they are weak, so they won't dissociate completely into OH minus ions. Okay, that was it. We talked about the pH scale a little bit. From 0 to 7, the pH scale varies from 0 to 14. From 0 to 7, we have acidic solution. At 7, we have neutral, and from 7 to 14, we have basic solutions. Ma'am, difference between answer, how will you come in a board? How much possibilities is there? So basically, the difference won't come. It is just an introduction I'm giving because we will be solving questions. The questions will come. The CBSE paper pattern has changed a bit, so they are mostly asking about the application-based questions. Okay, so you need this knowledge. They will give you question, and in there these things will be given. Then you need to figure out what they are talking about. As you will see in the questions that we will be discussing today. H3PO3 is a weak acid. It is not a weak acid, Pika. Okay, Ankush ka doubt tha. At room temperature only, ma'am. pH, yeah, it does get affected by temperature. Yeah, at room temperature. 3PO3. Okay, Bhuvnesh, we will do questions. Okay, so now we'll discuss the chemical properties. I'm discussing these things with you because we will apply this knowledge in our question part. Okay, what are the chemical properties of acids and bases? See, so first one is, we'll talk about bases first, then we'll do acids. Okay, Pradni, I don't think you need the answer for that question. Okay, so the bases, your bases, they react with metals. Okay, first reaction is, how do your bases react with metals? So when your bases react with metals, we get a salt plus hydrogen gas. See, the question comes like this. They will give, you have a metal oxide, they will give a base actually, and they will tell you how will they react with metals. So the question might be like this only. Kya hoga question? They will ask, for example, how does sodium hydroxide, the question is here only, how does sodium hydroxide reacts with zinc? How does sodium hydroxide reacts with zinc? How does sodium hydroxide reacts with zinc? Or they will ask, which gas will be evolved when sodium hydroxide reacts with zinc metal? Ma'am, are you from pH table, is it? Yes, ma'am, all bases do not react with metal. Yes, all bases do not react with metal. Obviously there are exceptions to it, but the bases that we are talking about here are your strong bases, okay? So they do react with metals. Your strong bases do react with metals, but the bases that are weak in nature, you know, they won't. When your bases react with metals, we get a salt of your metal and base plus hydrogen gas is evolved. So normally when your hydrogen gas is evolved, it gives a pop sound. Hello, Leno. Hi, ma'am. Board not visible. Hold on a second. Just give me a minute, huh? It will be visible. The camera is having some issues, I guess. Okay, Swati, I will change the color. Just give me 2 minutes. The camera will come in focus. Is it still like that? Can you let me know if it's still in blur? Kids, can you let me know if it's still in blur? I have changed it, like the camera, there was some issue with the camera, now it's, I think, okay. Okay, Praneet, it is visible, right? Swati, can you see the screen now? Okay, so it was the camera issue. So where is, I'm sorry guys, there were some issues. Abhi I think it's resolved. So Ankush, to answer your doubt, KOH is a strong base, okay, so it is very reactive. It will react with most of the metals, but there need to be some conditions, you know, there need to be some condition you need to change or alter so that the reaction will happen. For very reactive, in the reactivity series you have, when you will talk about metals and non-metals, there is a reactivity series. You can see the potassium lies at top of it, okay. Now the metals that are below it, it does react with those metals, okay. But the metals that are very low in the reactivity series, your potassium does not react with those metals unless you alter heat and provide some other catalyst or something, okay. Only 10 students join. Why? What are amphoteric oxides? So Swati, amphoteric oxides are those oxides which react with both acids and bases. You know, they react with both acids and bases. That's your amphoteric oxides. Your acidic oxides react with bases only. Your basic oxides react with acids only. What? No, Satyendra? Yes, Swati. No voice. Just give me a minute. Am I still not audible? Hello, hello. Screen, I'll try to. No worries. Hello, hello. Am I audible first of all, guys? Kids, am I audible? I'm not audible. Manish is saying it's okay. Fully audible. Thank God. Okay. No worries then. The camera thing is still an issue. I'm sorry, guys. I'll try to. Whatever I'm teaching, I'll try to write it again, okay? Okay, good. Okay, 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 Manish. Okay, Satyendra. Fine, okay. So, Bhuvnesh ko bhi sun raha hai? Yes. Okay, Ankush. Bhuvnesh, carbon and its compound we will do, okay? It's in the series only. So do follow the WhatsApp channel link. There you will find all the links and all the schedule and everything, okay? So go there and you will see the carbon its compound is there only, okay? We will complete it. Okay, so this was the reaction of bases with metals. How do they react with non-metallic oxides? Now, metal or metallic oxide, obviously they won't react. They are same, right? They won't react. Hello, legend. Yes, Satyendra, I am doing the class. Okay, so your non-metallic oxides, they are acidic in nature. Reaction with non-metallic oxide. So your non-metallic oxides are acidic in nature, and you know when acids and bases react, you get a salt. No, Lenovo. Pradni ma'am, JJ ma'am teaches your biology, so do follow her. Reaction with non-metallic oxides. Okay, so when your bases react with your non-metallic oxide, we get salts. Why? Because your non-metallic oxides are acidic in nature. Okay, so we get salt plus water. There is no gas there. Okay, you'll just get salt plus water. Okay. How does your acids react with metals? Same way, your acid reacts with metal. You see, your acids are your 1 minute. Okay, so your metals are basic in nature. Your metals are basic in nature. When acids and bases react, we get salt plus hydrogen gas. Plus hydrogen gas. Acids plus metal, we get salt plus hydrogen gas. Hello, what is your name, ma'am? Second. Manish, my name is Ekta. You can call me Ekta, ma'am. Bhuvnesh, amphoteric oxide. Amphoteric oxides are those oxides which react with both acids and bases. You have few examples. You have zinc oxide, you have aluminum oxide, you have lead oxide. These all are examples of amphoteric oxide. Oxides which react with both metals and non-metals. Hello, Swati. Hey, bhai. Good afternoon, Vidya. Yes, legend. Metals are generally basic in nature while your non-metals are acidic in nature. Swati, do not worry. We have that lecture scheduled as well. We will complete that chapter. You need not to worry. Your Ekta Ma'am is here. Okay. So, when your acids react with metals, it's like a neutralization reaction because your metals are basic in nature. Your acids are acids. So when your acids and bases react, you get salt plus hydrogen gas. As one reaction, your HCl is an acid, zinc is a metal, so you get ZnCl2, zinc chloride, plus evolution of hydrogen gas. Okay, now the second chemical property of your acid is they react with metal carbonate and metal hydrogen carbonate. Okay, they react with metal carbonate and metal hydrogen carbonate. Okay, Arush. Okay, Arush. Yes, Manish. Now your acid reacts with metal carbonate and metal hydrogen carbonate and you get salt. Again, there is metal, right? Metal carbonate or metal hydrogen carbonate. They are still basic. So you will get a salt, okay? Whenever there is an acid-base reaction going, you will get a salt, okay? The rest products will vary. For example, for your metal carbonate and metal hydrogen carbonate, you will get carbon dioxide plus H2O. Carbon dioxide plus water. So in some reaction you saw there is hydrogen gas evolving, right? But in some other reaction there is carbon dioxide also evolving, okay? So it depends on what kind of reaction we are talking about. You need to remember this. Okay. Salt, water and CO2. Correct, legend. Okay, your name is Pradnya. Pradnya, is it pronounced as Pradnya? test for CO2 gas. There is no test for CO2 gas. Normally you do the one for carboxylic acids. There you get the brisk effervescence. There is basically your CO2 gas is released. That's your test. That's how you know if it's in carboxylic acid or alcohol. Okay? Pradnya. Okay, Pradnya. So, when your acid reacts with metal carbonate or metal hydrogen carbonate, you get a salt, your carbon dioxide plus water. Okay? The reactions are like this. Na2CO3 is your metal carbonate. NaHCO3 is your metal hydrogen carbonate. We will discuss them in details. Okay? How do you prepare them and what are their common names? Okay? The last reaction of acids is reaction with metal oxides. Guys, can you check if the board is visible to you or not? It will get blurred, but I hope you will see it. Yes, Brijesh, tell me your doubt. And yes, it can be used as a test for carbon dioxide also. Yes, correct, Rohit. Yes, Manish, tell me your doubt. Yes, Manish. Yes, Pradnya. Brijesh. Okay, it's not blurred, it's clear. Okay, Arush. So, how do your acids react with metal oxides? You know, in your 10th class, you have this one reaction, which is like the OG of all reactions. That's been asked like every single year. We'll talk that. So, we have calcium oxide combining with water. We get calcium hydroxide. Okay, now this calcium hydroxide is called your lime water. Like this whole reaction is there, which is in continuation, and like they will ask the parts of this reaction, some place or the other place. No worries, I'll rewrite it for you. Okay, so now this calcium hydroxide, it reacts with carbon dioxide. Okay. You get calcium carbonate. What is metal oxide? Metal oxides are when your metal react with oxygen. Whenever there is a metal reacting with oxygen, we get metal oxide. Metal जैसे sodium will react with O2 and we get metal oxide, which is Na2O. Calcium carbonate formed. Yes, and then finally आगे भी होता है. It further reacts with CO2 plus H2 or something. Decomposition happens, calcium carbonate बनेगा, then calcium hydrogen carbonate बनता है, plus H2O is there. HCO3 twice. This is insoluble. And this is soluble. This whole reaction is there. Like part maybe पूछेंगे कैसे भी, but this is there. Just remember this reaction. Lime water, you call that, I think, quick lime. Slake lime, you also call that this is slake lime. And this is lime water, you call that calcium hydroxide. Slake lime, hydrated lime. The camera will go blur again. Hi Marco. Slake lime, the name is slake lime. CaO is your quick lime, this is quick lime. And this is your slake lime. Yes, Brijesh, correct. Once again, what happened, Manish? Hi, Marco. Hello. It's very difficult to learn. Yes, I'll give you some mnemonics, don't worry. Yes, the distinction, like the difference is a little bit tricky, yeah. All clear. Okay. So, how does your acids react with metal oxides? Again, your metal oxides are basic in nature. Metal oxides क्या होते हैं? When your metal reacts with oxygen, we get metal oxides. These are your metal oxides, right? Calcium oxide, sodium oxide, magnesium oxide, MgO, right? These all are your metal oxides. Now, when the metal oxides react with acids, we get a salt plus water. Salt plus water. Okay? Okay, legend, it's clear. These are all the reactions that are there, which are very important for your exam point of view. So I have summarized them all like in a mind map. Okay, this is a mind map. So focus on these reactions, okay, and the products that are getting formed. Okay, and we apply this knowledge in question solving. Magnesium and nitric acid, right? So magnesium is a metal, nitric acid is acid again, so you get salt, magnesium nitrate, MgNO3. You will get Mg, yeah, NO3 also twice, no? MgNO3 twice. My name is Manish, not Manish, Manish. Sorry. GNO3 twice. Okay, Amanish. I'm sorry I did not know your name. I thought it was small for something. Okay. Where was it? Whose doubt was it? Brijesh, so when magnesium react with HNO3, you get MgNO3 twice plus NO2 plus H2O. You get magnesium nitrate, okay, and it's a salt. What kind of salt will it be? Give answer. Brijesh, I have given the answer. What is the difference between cycloalkane and an alkene as they have same formula? There is a ring there. It's okay, ma'am. Yes, it does evolve H2 gas, salt plus hydrogen also, but you have multiple ways it can react. It can also evolve like this only also, because you can treat it as like depend on the concentration you are using, depend on the amount that you are using. Yes, Brijesh, hydrogen gas evolve hoga. Similarly, you can also write water will also evolve. No worries. You have other different type of reactions. You can just write it two ways. You can just write it MgHNO3, this one, plus if this is one possibility, and the other will be, you can just write as H2O, sorry, hydrogen gas, because it's a metal. From Amnish, okay ma'am, from this chapter does pH of salt will be asked. pH of salt, you know, na, it's if it's neutral salt it's 7, if it's acidic it's less than 7, if it's a basic salt it's more than 7. This chapter, the question that will be asked, okay, salt again, how are your salts? pH, color. So the Shilu, from pH you need to memorize the color for indicators only. The question comes from indicators. So they will give you an indicator and they will ask the color change for an acidic and a basic solution. That type of question comes in your CBSE board. Okay, you don't need to remember every color. There are 3-4 indicators. We will run them. Okay. हाइड्रोजन गैस इवॉल्व होगा, हाँ ब्रिजेश, अगेन हाइड्रोजन गैस इवॉल्व होगा रिएक्शन में. ओके, सो nitric acid strong oxidizing agent itself reduces to NO3 and oxides H2 to H2O. Yeah, but you can also just stop it at magnesium combines with nitric acid and you get magnesium nitrate salt, okay, and plus hydrogen gas. You do not need to deal with too much of complications because only that reaction is important, because we are talking about when metal reacts with acid, we get salt plus hydrogen gas. With other metal also you will get salt, because your nitric acid is a very strong acid, and when a strong acid reacts with a metal we get salt plus hydrogen gas. Okay, okay kids, now how are salts formed? They are the product of neutralization between an acid and base. There are 3 types of salt. You have acidic salt, you have neutral salt, and you have basic salt. They are formed by different combination of acids and bases. So when you have strong acid plus weak base, then you get an acidic salt. When you have a strong acid plus strong base, you will get a neutral salt, and when you have a strong base plus weak acid, you get a basic salt. Yes, they will ask questions like this. Yes, they will give you a reaction, then they will ask what kind of salt you will get. Will it be an acidic salt, basic salt, or a neutral salt? Yes, question comes like this. Aqua regia is a 3:1 mixture of your HCl and concentrated HCl and concentrated HNO3. Salt plus, yes, legend, the reaction is correct. Brijesh, just write your doubt in a proper way. What with other metal? Okay. These are the different type of salts that were discussed in your chapter, acid, bases and salts. Okay, only these salts are required. I hope the screen is visible. Brijesh, there are 10 molecules of water attached in your washing soda. Which is Na2CO3.10H2O. Yes, legend, correct. Swati, do you know for what purpose we use aqua regia? So cat lover, your these notes will be available on the WhatsApp channel, on the Deeksha Vedantu class 10 WhatsApp channel. There I'll upload the PDF. Okay, from there you can get these notes. Yes, cat lover, for making gold sign, not exactly the gold shine. The purpose is for, you know, when you have very unreactive metals like silver, like gold, like platinum. These metals do not react with acids, okay? They're very unreactive, noble metals. So to react them, you know, to form a compound of these metals, you use very strong combination, this combination of aqua regia. It reacts with noble metals, okay? Namaste Arihant. Why we need baking powder of cooking if you already have baking soda? Depends on what kind of food you're preparing. Baking soda is different and your baking powder is different, okay? Both have different composition. Arihant, Tanvi ma'am is really good. I'll tell her that Arihant asked about her. Yes, cat lover, correct. Making gold shine. Sorry. Okay. So Brijesh, carbon does not gain 4 electron because when you try to, like when carbon tries to gain 4 electrons, so every additional electron will add 1 negative charge. Okay, and 1 negative charge, to balance that negative charge you do not have enough protons. Okay, there will be stronger repulsion between the electrons in the valence shell also. Okay, so due to these two reasons, there is not enough protons to hold the electrons, and the second reason is there is inner repulsion. There is a repulsion between the valence shell electrons also. Due to that reason, your carbon does not form a C4 minus, a tetravalent anion. Done. Okay, so first salt is your common salt, NaCl, table salt you call it. Yes, Arihant, it can't lose or gain 4 electrons. That's why it shares these 4 electrons. Okay. That's one way to explain. There are multiple explanations. Okay, so this one is simple one. See, when you know a structure of atom, right? There is a nucleus, there are surrounding shells and everything. Okay, so there is repulsion between the outer electrons also, and the number of protons is also less. So that's one way to explain it. Okay, and that's the correct explanation actually. You tell then. Okay, Brijesh, you explain it. Okay, so how do you prepare your common salt? NaOH plus HCl, we get NaCl plus H2O. That's how you got your common salt. Caustic soda. Caustic soda is sodium hydroxide. Okay, how do you get your caustic soda? You take a brine. This is your brine. And you electrolyte that, you provide electricity to that brine. Okay, and that's how you got NaOH plus Cl2 plus H2. This NaOH is your caustic soda. This chlorine gas is used to make bleaching powder. Royal wattage deals with noble metals like platinum or gold or silver, and hence we can say that it is highly corrosive in nature. Yes, Arush, it is highly corrosive in nature, correct? Yes, good. Yes, Arihant. Okay, So your caustic soda, that's how you get your caustic soda. You take a brine and you provide electricity to it. You pass electric current through it, and then you got NaOH, Cl2 and H2, right? The anodes and cathodes पे you get H2 and Cl2. Okay, anode पे you get Cl2. You get anode पे you get Cl2, and your cathode पे you will get hydrogen gas. Okay. Bleaching powder. It is also a very, in tanning industries to bleach hairs also, and to, bleach your clothes, this all is bleached. Okay. So to use that, like how do you do that? To accomplish that purpose, you use bleaching powder. How do you prepare bleaching powder? You take lime water, CaOH twice, and you pass the chlorine gas which you got from the process, this above process of caustic soda. Okay, this is also called chlor-alkali process. This process name is chlor-alkali process. Arush, the mnemonics could be see. Actually, Arush, I don't have any mnemonics as such, but this is the summary here. These are all the required salts, and if you get confused or something, see, we can make something out of it, I think. Common salt cause breaking. I'll try to come up with some mnemonics, okay? When I upload this PDF, I'll add an additional page where the mnemonics will be there, okay? I try to shorten it out by like writing all the salts that are required and that are in your book that are very important, but I will add an additional page in this PDF and then I'll upload it, okay? Right now I don't have the mnemonics. Okay, so how do you prepare bleaching powder? This is the formula of bleaching powder, CaOCl2, okay? Okay, Arush. Then you have baking soda. What is the formula of baking soda? It's NaHCO3, sodium hydrogen carbonate. How do you prepare it? NaCl plus H2O plus CO2 plus NH3, you get NH4Cl, and uske saath you get NaHCO3. Your NaHCO3 is your baking soda. This is your baking soda. You use it for baking purposes. So different thing is there. Okay, to answer your doubt, I believe Arush, you asked it, right? Or Swati. Okay, so Arush, actually what happens is your baking soda is NaCO3. It's basic. Okay, when you need some slight acidity also, when you need slight acidity in your cooking process, so that then you use your baking powder. Baking powder. So what is your baking powder? Your baking powder is nothing but a salt of. It's a salt of this particular. There is an acid there. There is an acid plus this base, okay? Salt of baking powder plus baking soda plus a weak acid. Any weak acid you can pick. So there will be baking soda plus acid plus H positive ion, weak acid. A weak acid will be there. That's your baking powder. So when you need a basic, like when you need only this much, only CO2 you need, when you need NaCO3, only basic part you need. Something, cooking may be different type. I'm not a baker, I don't know. But the reason is to give some acidity, some taste difference ke liye. You use that. Yes, no worries. I'll try to find a mnemonic. I'll sit and I'll actually do some jingles or something. Don't worry. I'll give you with the mnemonics only. Okay, Arush? No worries. Okay, so the next salt is your plaster of Paris. Plaster of Paris or POP you can call it. It's a salt of calcium. Calcium metal ka salt, okay? The formula is CaSO4 half H2O. It has only half water of crystallization, okay? Hi Jeet. Yes, Arihant, but yeah, he's right, because when I was doing giving my exams, I also got confused in this a lot. So if a mnemonics would be there, it would be really helpful. Okay, so your calcium sulfate dot 2H2O, what is that? It's gypsum actually. When you remove 1.5 water molecule from gypsum, when you remove 1.5 water molecule from gypsum, you get plaster of Paris. You get plaster of Paris. CaSO4 dot half H2O. Okay. Yes, Jeet, I'm good. How are you? Then again, how do you prepare gypsum? You take your plaster of Paris, POP, and then you add the 1.5 water molecule that you released, you know, that jo aapne nikala idhar se. You just add that there and you get CaSO4 dot 2H2O. Okay, that's your gypsum. Calcium sulfate dot 2H2O. Okay. pH scale. What is a pH scale? It is a scale for measuring the hydrogen ion concentration. So the pH is equal to your, you do not need this formula, but I'm just telling you, you calculate pH using negative logarithm of H positive. Your H positive ion concentrations, unka negative logarithm if you take, you get your pH. Okay, this is your pH. And what is a pH scale? It is a scale ranging from 0 to 14. Okay, from 0 to 7, from less than 7 you have acidic solution. At pH 7 you have a neutral solution. At pH greater than 7 you have basic solution. Okay, there are bases here, there are acids here, and there is a neutral, anything that is neutral here. The question comes, if they will come as water crystallization, as I have seen in the sample papers also, the question comes, they will ask in MCQ only, as how many water crystallization does washing soda have? So Arush, question might come like this only. And yeah, how many water crystallization are getting lost when you heat that? For example, when you heat gypsum, how many water of crystallization are getting lost? Or they'll just simply ask how many water crystallization are there in gypsum. Okay. Okay, so your pH, that's how you calculate your pH. School chemistry teacher runs a new chemistry management institute. She will just learn that log formula and all log values, so she will give questions from the pre-board too. So Arihan, normally in your 10th class, they don't ask you to calculate using this formula, okay? It comes in your 11th standard. So I don't know why she's asking that, but it's a good thing. It's like you prepared, it's you getting prepared for 11th standard. Don't think she should do it. So look, no, Arihan, actually you should learn it. I am not saying complain or something. It's a good thing because in the next class you will learn it, okay? Okay. P, the pH ka P stands for potens, which is the German word which means power. Okay, the last thing that is there are your indicators. The last thing that is there are your indicators. So majorly the indicators that we will be using here, Arush or Arihant, okay. So you have litmus, phenolphthalein, methyl orange, and some olfactory indicators, okay. So your litmus paper, it turns with acid, your litmus paper, it turns red, from blue to red. With bases, what happens? It turns from red to blue. Phenolphthalein, your phenolphthalein is colorless in acidic medium. It is colorless. And pink colored in basic medium. Methyl orange is orange colored in acidic medium and yellow colored in basic medium. Your olfactory indicators, Yes, the phenolphthalein comes, but they all ask. Methyl orange ke questions are there also. Okay. The litmus is very simple, everybody remembers it, but phenolphthalein, methyl orange. Also, the olfactory indicators. 1-2 questions were there from the olfactory also. Like in a whole question thing, something was getting asked, but they were giving it, like the substance was giving different smell, was retaining their odor or losing the odor or something. So when your olfactory indicators, mainly onion, vanilla extract, these two are there. So if they retains the odor, so when you have the odor and they retain the odor, okay, this smell is still there, then the medium is acidic. You're talking about acids, okay? And if the medium is basic, it will lose its odor, okay? And now, please, question time. It is your question time. Yes, vanilla essence in onion. Same thing, one retains its odor, it's in acidic medium. If it loses the odor, it's in basic medium. Okay guys, now please try to solve as like with me, keep it up with me. I'll look for your answers, okay? And let's solve as many questions as we can. Vanilla extract, you can write vanilla extract. Actually, either is fine, but you can write vanilla extract. Okay, Arihant. Legend, how many types of indicator? Majorly, there are 2 types of indicator, natural and synthetic. PPT or precipitate. So, Arush, PPT or precipitate are your insoluble salt that are formed when 2 ions combine with each other, okay? So basically you get an insoluble salt. For example, if you were present in yesterday's class, we talked about your sodium sulfate and barium chloride, and we got barium sulfate and sodium chloride. This was a PPT. There was an exchange of ions, and we got an insoluble salt. These insoluble salt are called your precipitate or PPT. This was your PPT. That's how you represent your PPT. And this was the aqueous solution part. This was the soluble part. Precipitate. I hope that clears your doubt. Arush, you asked about PPT, right? Yes. So, on your screen, the first question. It's very easy one. Which of the following substances, when mixed with water, will result in a solution with the lowest pH value? So Arihant has answered C. See, lowest pH means pH is low. That means your solution is acidic. Your solution is acidic, right? So, out of these, what is the pH of milk of magnesia? Arush, milk of magnesia has a pH 10. Your human blood has a pH of 7.4 to 7.6, I believe. Your gastric juice has a pH of 1. Pure water has a pH of around 7. It should be neutral, okay? Okay, legend, tick. What should be the answer? Milk of magnesia is basic. Yes, Arihant, milk of magnesia is basic. And lowest pH means we are talking about acidic solutions. We are talking about acidic solutions. Yes, it's 10. So the answer is C. Yes, Arush, it is 10. So the lowest pH we are talking about. Now we are talking about the lowest pH. The lowest pH will be of the solution which is highly acidic. Out of these, the gastric juice from our stomach, it is highly acidic. Yes, Arihant, you were right. Okay, Arush, your answer. Give me correct answer in the next one. When dilute hydrochloric acid is added to solid sodium carbonate, again you have acid plus sodium carbonate. We just discussed it. Okay, the observation is, now you see why that all revision was important. Yes, guys. Okay. No worries, Arush. Your answer was correct. Like, you did not understood it, I think. You took the pH one in a different way. It's okay. So when dilute HCl reacts with, I'll write the reaction, HCl. Hello, hello, am I audible? Hello guys, so sorry, you're back. No, yeah, there was some problem with the camera and stuff. It's okay. Hello, sorry. Am I audible? Hello. Just let me know in the comment section, please, if I'm audible or not. Asta, am I audible? Okay. Okay guys, I'm audible. Okay, the answer is C. The answer is C. You had plenty of time to solve this question. When HCl reacts with Na2CO3, sodium carbonate, you get sodium chloride, carbon dioxide and water. This carbon dioxide, it gives brisk effervescence. It gives brisk effervescence and it's colorless and odorless gas. It's colorless and odorless gas. Okay, Astha, thank you. Okay, moving on to the next question. Question number 3. Yes, C was the correct answer. Correct, Arush. Question number 3. Soaps are not effective cleansing agents in hard water. Your hard water are nothing but calcium and magnesium salts. Okay, your hard water has a high concentration of calcium and magnesium. Okay, this is your assertion. The reasoning is soaps form insoluble precipitate scum. You call that insoluble precipitate scum on reaction with calcium and magnesium ions present in hard water. It is correct, right? Because there is calcium and magnesium ions present in hard water. So, what should be the answer? Okay, kids, what should be the answer? Arihant, are you there? Legend? So Legend, actually the screen got blacked out and then I tried to switch it on. Now it's working. No issues here. Okay guys, so the answer is A, which is both assertion and reason is correct, and your reason is the correct explanation of A. A means assertion, okay? Because soaps are, you use detergents, okay? What do you use in hard water? You use detergents in place of soaps because they do not form scum, okay? Next question on your screens. A few drops of phenolphthalein indicator are added separately to a solution of vinegar and a solution of washing soda. You have vinegar and you have washing soda. So what are the observed colors? What are the observed colors? This one question we also answered. We just discussed this. Vinegar. Your vinegar is acidic. Your washing soda is basic in nature. Okay. When you put phenolphthalein in acidic solution, what is the color change? And when you put phenolphthalein in basic solution, what is the color change? I am audible, right? I'm audible, guys? See, when phenolphthalein is in acidic medium, it is colorless. And we have two options here. Hi, Prem. And when your phenolphthalein is present in basic medium, the color is pink. Color is pink. So that means the correct answer is B. B is your correct answer. Legend, A is not the correct one. See, vinegar is acidic, right? And in acidic medium, your phenolphthalein is colorless. Yes, correct, Legend. Hi, Prem. Thank you, Prem. Okay, moving on to the next question. Arrange the following substances in increasing order of pH value. See, increasing order of pH values. Increasing means you're going from 0 to 14. That means you're going from acidic to basic. Okay, increasing order में. Hello Aksh. Thank you Prem. Hello Aksh. Hello. Okay Priyanshu, thank you for clearing. You all are my favorite students. Okay, so just tell me the answer of this question. Just tell me the answer of this question first. So whoever answers this question first will be my favorite student. And the rest of the questions also. Priyanshu, my name is Ekta. I'm your Ekta Ma'am. Okay, Asta answered B. Prem answered 3. Okay. Priyanshu also answered 3. Okay. Asta changed her answer. Okay, see, increasing order of pH, right? So the least pH will be the one which is most acidic. Among these, your lemon juice is the most acidic. After your lemon juice, the next one is your distilled water because the pH is 7. Lemon juice has a pH of 3. Toothpaste has a pH of around, I would say 8 or 9. It's like 8 to 10. It's in between 8 to 10. Sodium hydroxide has a pH of 14. So just the order will be your C. Lemon juice, distilled water, toothpaste, sodium hydroxide in the increasing order. So you guys were correct. Harshit C correct. Asta C correct. Prem answered first. Okay, let me see in the comments. Where is Prem? Okay, so actually Asta answered first, but yeah, you were the first one who answered correctly. Prem, I told you the one who will answer all the questions correctly will be my favorite student, and like you know, first सबसे पहले जो करेगा. Correct, Harshit. Asta is also correct. Priyanshu's answer is also right. Okay. Next question on your screens. Dilute sulfuric acid is added to sodium hydrogen carbonate. The gas evolved is then passed through freshly prepared lime water. Dilute sulfuric acid, HCl. Sodium hydrogen carbonate, NaHCO3. Gas evolved, the gas is carbon dioxide. Lime water is calcium hydroxide. What is the final observation? I have given everything. Just I am your teacher. I am your friend. I am your teacher. I'll be there to help you in your chemistry. So Prem answered first again. Harshit, C, correct. Okay. Arush also answered C. Astha also answered C, correct. Okay, so your gas evolved is carbon dioxide, and when you pass carbon dioxide from calcium hydroxide, okay, so you get lime water milky. Milky means you get calcium carbonate, okay, plus H2O. Your calcium carbonate is milky. It's milky. Yes, Priyanshu, correct answer. The answer is C. So the gas evolved. Observation is brisk effervescence occurs. Brisk effervescence means there is bubbling. There is bubbling. Bubbling kiska? Bubbling of CO2. And the gas turns lime water milky. The first one, reddish brown gas is seen, while which turns lime water orange. It's not there. Nitrogen. Reddish brown is your nitrogen dioxide. No gas is evolved. Incorrect, because there is a gas evolved. Solution becomes hot and the lime water remains clear. Oh, nothing like that is happening here. Arush, we have to finish 15 questions. So if you answer correctly and on time, it will end soon, okay? Are you getting tired, Arush? Okay, moving on to the next question. Which of the following correctly represents the nature of aqueous solution of HCl gas and NH3 gas? So we made an aqueous solution of HCl and NH3. HCl and NH3. We made an aqueous solution of them. What will be the nature of? What will be the nature of these solutions? When did I ignore you, Prem? I answered this question. Okay, Arush, charge your phone. Okay, tell me the answer of this one. Arush answered C. Astha also answered C. C. Suji Justin. Okay, Suji, you also answered C. Astha, C. Okay. Yes. So, your HCl, solution of HCl in aqueous is HCl plus H2O. We get right, and your NH3 and water, we get NH4OH. This is a base and this is an acid. So your HCl is acidic and your NH3 is basic. Your answer was okay. So HCl acid and NH3 base. Correct, Priyanshu. Suji, the answer is C. HCl is acidic and NH3 is basic. Next question. Dry hydrogen chloride gas does not change the color of dry litmus paper because. Answer this one then. Yes, Arush. Suji, I hope your doubt is clear. It was not basic. One is acidic, one is basic. The reactions I have written there. Yes, Priyanshu. Okay, so dry hydrogen chloride gas does not change the color of dry litmus paper because there are no H positive ions. There are no H positive ions. So to get the hydrogen ions or the hydronium ions, you need to give water, like put that hydrogen HCl gas in water. Somehow you need to make an aqueous solution of that gas. Prem, I'm waiting for your answer to this question. Question number 8. So the correct answer will be B. It does not ionize without water. Without water, there are no H positive ions. Next question. No one answered that question. I am looking for the answer of this question. What happens when excess carbon dioxide is passed through lime water? What is the correct answer? Yeah, sure, Arush. I will tell, but you have to answer all the questions. All the questions. You're not answering. The last question no one answered. Harshit says C. So Arush also says C. Okay, Harshit. Okay, Arush. Yes, Harshit. Prem answered A. Now see, when you treat lime water with excess carbon dioxide, excess means बहुत सारा carbon dioxide है. So you have your lime water and you have excess of carbon dioxide. What should be, product क्या बनेगा? Think. I told you in the beginning of the class, this is a very important reaction. Okay, guys. Priyanshu, what's your answer, Priyanshu? Where is your answer? You have CaCO3 plus H2O. There is excess of carbon dioxide. That means there is more carbon dioxide. Now this carbon dioxide will convert this into, we have H2O, we have carbon dioxide, we will get CaHCO3 twice, which is your calcium bicarbonate. This is calcium carbonate. See, the difference is your calcium carbonate is insoluble in water. Insoluble slash it turns your water milky. It turns your water milky. But your calcium bicarbonate, calcium hydrogen carbonate or bicarbonate, it is soluble. In water. Prem, your answer is C. You answered A. Last question it was B, na? A. For the last question the answer was C. For this question A wala Harshit C. My answer is right. Yes, Asta, your answer is right. Okay, Asta, I'll be waiting for your. Prem, you have so many questions left. In the end, I'll reveal my favorite student name. Okay. Next question. Most non-metal oxides are acidic in nature, but some are neutral. Which of the following is a neutral oxide? Yes, Priyanshu, the answer was C. Okay, tell me the answer for this question. Most non-metal oxides are acidic in nature, but some are neutral. So which is neutral? Prem, answer the question first. C. Asta, what is the answer? Prem answered C. H. Ram Bahadur. Yes, ma'am, my answer is correct. C. Asta also answered C. Hello, Ram Bahadur. We have questions left. We have 5 more questions to go. Okay, so sulfur dioxide. Your sulfur dioxide, you will get this acid H2SO3. Okay, from carbon dioxide you will get H2CO3, carbonic acid. From here you will get H3PO3, which is your phosphoric acid. Only your carbon monoxide is there, which will not give you any acidic or basic oxides. It does not react with acids, does not react with bases. Okay. Yes, no, the answer is, hello Ram Bahadur. So, everyone, the answer is carbon monoxide. Correct, Priyanshu. The answer is carbon monoxide. It is neutral in nature. It is neither acidic nor basic. Normally, your non-metal oxides are acidic in nature. At the beginning of the class, we discussed. Your metallic oxides are basic in nature. Your non-metallic oxides are acidic in nature. But there are some exceptions to this. The exceptions are your carbon monoxide. Okay? It's neutral. It's a non-metallic oxide, but it's neutral. It's neither acidic nor basic. Asta, the answer is D. Okay, Prem? Okay. Next question. A curry stain on a white cloth is yellow in color. When soap is scrubbed on it, the stain turns reddish brown. What is the nature of soap and why does the color change? Yes, Priyanshu, the answer was carbon monoxide. Now answer this question. Arush answered C. Asta also answered C. Arush, are you going? Don't leave, kid. You have just 4 more questions to go. Stay with me. Yes, Asta. No worries. C. Harshit also answered C. I'll explain. Priyanshu, what is the answer? Prem also answered C. So, your turmeric or turmeric, whatever you call it, your turmeric is a natural indicator. Turmeric is a natural indicator. When turmeric is present in acidic solution and when turmeric is present in basic solution. So, in basic solution, it turns reddish brown, and in acidic solution it is yellow. जैसा इसका color वैसा ही, like haldi is yellow colored, right? So in acidic solution it will be yellow colored, and in basic solution it turns reddish brown. So now if it's turning reddish brown, something we scrubbed and it is turning reddish brown, that means the soap was basic in nature, and the turmeric acts as a natural indicator. Okay, so Prem, again I have told you, it's in the thumbnail also, my name is Ekta. I'm your Ekta Ma'am, okay? So the answer is C. Soap is basic in nature, okay? That's why the stain turned reddish brown. Yes, Asta, your answer was right, and Arush answer was also right, Prem's answer was right, and Harshit, correct answer, Priyanshu also correct answer, okay? So those of you who are answering, I'm actually counting it, so who will be my favorite student? Yes, Asta, your answer is right. Next question. A student takes 10 ml of hydrochloric acid in a beaker and adds 90 ml of distilled water to it. What will be the effect of on the pH of the final solution? Your HCl is an acid, right? Your HCl is an acid. That means pH is less than 7. And if we add distilled water has a pH of 7. So, what will be the effect on pH? Yeah, HCl has a pH of, let's say, it's actually near 0. I'll consider it 1. So, अगर HCl का pH 1 है and distilled water का pH 7 है, so effect क्या होगा if you mix these two? Priyanshu answered B. Okay. Correct. Okay, so the answer is the pH will increase. The pH will increase. pH will increase. So the pH will come from 1 to 7 is there. The pH will come around 2, 3. Prem, you did not answer the question. Next question. Bleaching powder is a yellowish white solid used for various purposes, including disinfecting drinking water supplies and as a bleaching agent for cotton in the textile industry. It is produced by the action of a specific gas on dry slaked lime. See, what is the formula of bleaching powder? Chemical name and formula of bleaching powder: CaOCl2. Calcium oxychloride. It is calcium oxychloride. The gas that is used in preparation, so the reaction was your calcium hydroxide reacts with chlorine gas that was produced in the chlor-alkali process, and then you got your calcium CaOCl2 plus H2O. This is your bleaching powder. CaOCl2 is your bleaching powder. Hi Aditya. Yes, Priyanshu, you answered A. What was the answer? The answer was B. Correct, Priyanshu. Asta, the question is theoretical. Okay. What happens when bleaching powder is exposed to air for a long time? So when bleaching powder is exposed to air, CaOCl2, when it is exposed to air for a very long time, in air we have carbon dioxide, it gets converted into broken down into calcium carbonate. So Prem, we just have 2 more questions left. 2 questions to go and then we are done. Hi Aditya. So Asta, what this is not an MCQ, it's a theoretical question. So what happens when bleaching powder is exposed to air? So when bleaching powder is exposed to air for a long time, it gets decomposed into calcium carbonate and chlorine gas is evolved. Okay. Second last question on your screen, guys. Some hydrated salts like washing soda lose their water of crystallization when exposed to open air. This property is known as answer this question. What is this property called? When hydrated salts lose their water of crystallization. This is their water of crystallization. Okay. When the hydrated salts lose their water of crystallization, what is it called? So Prem answered A. Hi Aditya. Hello again. B. Answer is A. So Priyanshu answered B. So actually deliquescence, this is read as deliquescence. The deliquescence is a property where if you have a substance and you add water to it, too much water to it actually, so it gets converted into this, instead of being solid, it gets converted into liquid, you know, this mushy liquid, I don't know, jelly type thing. Okay, so basically too much water in there, it also gets converted into liquids. That's called deliquescence. Okay, so while you add some water or solid to it, the solid gets converted into liquid, jelly liquid. B. Efflorescence. So Astha, you answered first. Okay Astha. So there is a tough competition going on, guys. A is the answer. See, so the answer is not A, obviously, because this is a different property. I told you, when you add too much water, here you're removing water. Your water is getting lost. This water is getting lost, okay, to open air. So that property is called efflorescence. Priyanshu answered correctly, and yeah, Astha also answered correctly. So Priyanshu, efflorescence is the property of, like, basically it is a property when too much, when a salt is exposed to air, the water is lost. So for example, छत पे देखा है जब बहुत बारिश होती है, जब छत पे बहुत बारिश होती है तो क्या होता है, व्हाइट कलर का एक लेयर बन जाता है उधर, राइट. देयर इज वाटर डिपोजिशन. वहां पे पहले क्या आएगा, बारिश का पानी. बारिश के पानी में कितने सारे सॉल्ट्स हैं, सो मेनी सॉल्ट्स है, राइट. सो व्हाट हैपेंस एग्जैक्टली कि basically when that water gets evaporated, salt deposition is left, right. So that salt deposition, that process is called efflorescence. That process is called efflorescence, okay. The salt deposition that are left after the removal of water molecule. And how does that happen? When these salts are exposed to open air. When these salts are exposed to open air, okay. That's your efflorescence. I hope it's clear, Priyanshu. The answer is efflorescence. Now, last question, okay. Are you guys ready? Hi Aditya, hello. Astha, achha. Last question. A farmer finds her soil to be too acidic. She decides to treat the soil with slaked lime. What will be the effect of this action on the soil's pH? Yes, Priyanshu. Last question, guys. Answer it. It is very easy. And I have the name. What is the answer? A farmer finds her soil to be too acidic. She decides to treat the soil with slaked lime. What will be the effect of this on the soil's pH? So this acidic pH was acidic. Added slaked lime. What is slaked lime? It is basic. Okay. So what will be the effect? Prem answered B. So what about the rest? What is the answer? So you had answered KRK. I am so sorry, I lost your answer. What did you answer? So your answer is Hello. I'm so sorry. There is an issue going on. It's okay. I hope it's clear now. Hi Priyanshu. Hi Prem. Hi Goku. Goku, you came. Hi Aditya. Sorry. So the correct answer is the pH will increase. The pH will increase. Okay. That's a wrap, guys. Everyone. Okay. Hello. Okay, so I hope you really liked this session. Okay, if you really liked it, please give it a thumbs up and do subscribe to this channel, Deeksha Vedantu class 10. And also there is a WhatsApp channel also there. There you'll find all the links in the PDFs that some of you were asking for it. Okay. For knowing my favorite student, please come in my next class. I'm counting how many lives I'll have. I'll count the questions that you're attempting, and then in the end I'll give you a score. Okay, only one class can't decide that, right? Maybe you won't come in the next class. I want you all in my next class, so please come there. I'll tell who is my favorite student in the next class. Okay. Priyanshu, yes, okay. Hi Vishal, hi, hello everyone, bye. Please do subscribe to the channel and give it a thumbs up. Okay. Arey Prem, don't do that. I will be looking forward to meet you. Okay. Okay guys, have a great day, take care, and bye bye, all the best.